Welcome back to In Depth with Academia. I'm Richard Price, the founder and CEO of Academia.edu, here to take you deep into the world of scholarly research and hopefully make it, a bit more accessible and even fun. Today, we're diving into a technical but really practical topic for anyone curious about how computers see and judge image quality. I'll be summarising and neutrally presenting the core ideas from a paper entitled Evaluation of Detection Methods in an Image Edge Error Measure, authored by Hartmut Für, Julio Cesar Garcia Alvarez, and Jesus Chavez. Remember, I'm just summarising their work. Nothing I say here is an endorsement. Think of me as your friendly research tour guide, not a judge. Let's get started. So, what's the big question our authors are tackling? At its heart, this paper is all about image quality assessment. Basically, how do we teach computers to measure the quality of pictures in a way that aligns with how people perceive them? More specifically, the authors focus on the edge error measure, a technique that looks at how well the edges, the lines and boundaries in an image, are preserved even after the image is distorted by things like JPEG compression, blurring, or noise. Why is this significant? Well, think about how you recognize a face or a tree in a photo. It's those edges that define objects. If an algorithm can reliably judge edge preservation, it's one big step towards automatic, human-like image quality assessment. Now, there are a lot of methods to detect edges in images: Sobel, Prewitt, Roberts, Canny, Laplacian of Gaussian, and more. But here's the issue. Not all of them work equally well in all situations. They each have strengths and weaknesses, sometimes missing subtle details, or, being too sensitive to random noise. So the real question here is, which edge detection method creates an error measure that matches human judgments best? And how can these methods be improved? All right, diving into what they did and what they found. The team evaluated several edge detectors, including the classic ones I just mentioned, by comparing how their edge error scores matched up with human opinions about image quality. For this, they used a large database of images, some original and some distorted by different processes like JPEG, JPEG 2000, Gaussian blur, white noise, and fast fading volunteers. Humans, that is, not algorithms, rated image quality, creating a gold standard to compare with the automated methods. A major contribution of the paper is their testing of a wavelet-based edge detector. Yeah, wavelets. If you're not familiar, wavelets are a kind of mathematical function that can analyze images at multiple resolutions, kind of like zooming in and out to see both big shapes and tiny details. Their wavelet-based edge error measure, or WEE, aims to catch important edges more reliably, even when the image is noisy or blurry. So, what did they learn? The WEE approach generally outperformed traditional detectors across all distortion types. For example, when assessing images messed up by JPEG or white noise, WEE's accuracy, measured by how closely its scores matched up with human ratings, was really high. We're talking correlation numbers in the 0.9s. That's kind of impressive for this kind of work. The Canny detector also performed well, especially for images affected by fast fading or Gaussian blur. Interestingly, while classic detectors like Sobel, Prewitt, and Roberts have their merits, they just couldn't keep up with wavelets in most cases. However, there's a trade-off. The wavelet-based method takes longer to compute, sometimes several seconds per image, while others, like the Laplacian of Gaussian or Canny, run much quicker. So if you care about speed more than absolute precision, that's something to consider. And here's a side thought that popped into my head while reading. What if someday we have to teach an AI system to recognize not just edges in photos, but like in paintings or comic books or something even weirder? Would these same edge detectors cut it? Not sure. But back to the main thread. To recap for you, the listener, what does all this mean for your daily life or your work? If you're building, say, a photo app, an AI tool to judge image quality, or even just tweaking your camera's software, the edge error approach, especially using wavelets, might give you results that feel closer to what humans actually see and value. But as always, academic research is not the final word. It's another perspective, a tool for your toolbox, not a commandment from on high. Each edge detector is a bit like a different lens to see the image. And, just like with regular glasses, the best one depends on your situation. The work by Hartmut Für, Julio Cesar Garcia Alvarez, and Jesus Chavez suggests the wavelet-based approach is a strong contender if you can spare a bit more computing time, and on that note, I'll wrap up. Remember, every paper is just a step in a conversation, never the last word. I encourage you to explore the methods yourself, see what works for you, and always keep questioning the assumptions, even the ones hidden in your favorite software. Thanks so much for listening to In Depth with Academia. I'm Richard Price, your neutral, curious host. See you next time.